Welcome back to Numerical Computing. I'm your host, Paul Constantine. Welcome back to Numerical Linear Algebra. I'm your host, Paul Constantine. The next problem that I want to look at is a problem that you have known since grade school called subtraction. The first is the partial of f with respect to the first component, and then the next, it's the max of the absolute values of the row sums. And so here we only have one row, and so this becomes, I want to draw a picture for you to sort of emphasize that idea of local sensitivity. Okay, let's say that with two subscripts representing their position in the row and position in the column, respectively. The first one. Let's get excited. So you might not think of it this way, but this is a matrix. The direction defined by Q1. And I'm going to take that projection, I'm going to subtract it from A2. Last thing I want to do is a graphics demo. These vectors over here, back in the domain, back in the unit ball, this is a set of orthonormal vectors. So I want to talk through these three lines really quickly to let you know what's going on. So this first line is just generating the Vandermonde matrix. Now,
so you said linear systems in the real world. Now, I'm as much in the real world as Paul is, and as much as anyone is these days, which is not really in the real world. So this is a linear system that would help you understand where an infection would go in a small probability scenario.
I started becoming interested in computational modeling when I was in school, in college. What it amounts to, sort of computationally, is basically solving a linear algebra system, AX equal B. At the end of the day, you solve that AX equal B, and the result is actually the aerodynamics performance of that object, that airplane and so on, which is, to me, was like incredible that you could actually get the aerodynamics, how much lift you're generating and so on out of solving an AX equal B type linear system.
yeah.
Sir Isaac Newton, born Christmas Day 1642, was an English mathematician, physicist, astronomer, theologian, and author who is widely recognized as one of the most influential scientists of all time and as a key figure in the scientific revolution. I just read that off Wikipedia. Gauss co-invented the telegraph in 1833. The first message passed was, "Knowing above believing, reality above appearance," which is more interesting than your first text.
Class, I'm very excited to introduce our next guest. Caden Adams is a computer science major in their last semester.
So I've been in Boulder, Colorado since I was about 8.
Okay.
So before then it was all over the place. Born in Belgium and then moved to Hong Kong and then moved to Michigan.
Oh, wow. So do you speak French and or Flemish?
Nope.
Okay.
My parents decided it was more important that I learn how to socialize than I learn French. I disagree.
Oh. Korean, please welcome Grace Horton. Grace, very happy to have you here.
Computer science is very useful all around the board, especially because of data collection and data analysis, which is something I'm very interested in pursuing myself. And I actually don't hate the math for it too, which is exciting.
Good. Sometimes I like to take a fall drive, and I think nonlinear is such a funny designation. When I was in grad school, I had a laptop, and since I had a laptop and I had an interest in music, I was making music on my laptop. Coefficient c sub k times x raised to the kth power. There's our degree d polynomial. And now the goal is to figure out what these coefficients are. Ready to play. This is Life Coach Paul. Don't be afraid of the grade, okay? Welcome to my kitchen. Today I will be preparing a Thanksgiving meal for myself.